Welcome, everyone, to this session. I'm going to be talking about the data science experience within Fabric. Hope you're enjoying SQL Bits so far. And before I get into the presentation, a little bit about me. My name is Barry Smart. I graduated about 30 years ago with a physics degree, and I started my professional career as a software engineer in the water industry. I was really lucky. I spent 4 years working in Australia for Sydney Water, and then I came back to Scotland, where I joined a power company, and I kind of spent my formative years there as chief architect for their energy trading business. Then I switched sector into financial services, where I was promoted to CTO. I helped that company to adopt the public cloud. In fact, we were the first financial services company in the UK to put personal data onto Azure. So that was a really interesting phase of my career. And actually, during my time at this company, I rediscovered my love of software engineering, coding, and data. And I changed gears completely. I took a career break. I returned to my alma mater, Strathclyde University, and I completed a master's in artificial intelligence. And now I'm Director of Data and AI at Engine. Engine is a small technology consultancy. We're completely remote. We're based here in the UK, but we've got a global customer base. We're a small team, but we achieve big things, and we like to help our clients do exactly the same by sharing our expertise, our processes, and our intellectual property to help them do exactly that as well. When we approach data projects of any type, we like to have this model in our mind, and it's recognizing that data is a socio-technical endeavor. To succeed, you need to master the cultural, organizational factors as much as the technology. And there's things like Conway's Law that come into play. How many of you have heard of Conway's Law? It's a really interesting concept, which basically means that the organizational factors at play will often overcome the architecture that you're trying to deliver. So if you've got a disconnected set of teams trying to deliver something, you'll end up with a disconnected solution, and obviously that's where problems come from. So this simple model describes the socio-technical system in a very simple way. You've got the data team on the left. They build a data product which meets the needs of the users on the right. So you've got a flow of value from left to right, but also, as important, as we'll hear, you've got feedback loops, and those feedback loops allow you to understand how the product's being used. In fact, the whole process starts with a feedback loop. It starts with understanding the goals and the needs of the business, and that feedback loop needs to persist over time. And it's all about achieving a rapid and safe flow of value and being proactive, reacting to what you're hearing in the feedback loops. High-performance data teams also adopt a product mindset. You'll see in the previous slide I used the terminology, a data product. It's a unit of value that you're delivering to the business. It's data-driven, and applying a product mindset to those data products is really helpful. High-performance data teams act as an innovation center within the business. So they're not there sitting as order takers. They're out there proactively helping the organization to think of ideas around how they could leverage data, and then to take those ideas through this innovation life cycle. And they accept that not every idea is worthy of going into production. They're prepared to pivot, and in many cases fail fast when those ideas are proven not to be viable. And that capability in its own right is really powerful, and organizations that succeed in innovation and adopting this product mindset typically are the ones that win in the current digital environment that we see ourselves in. The machine learning lifecycle, I'm sure you're all familiar with this, is basically a specialized form of the product lifecycle. You could turn this into a linear process, a bit like the product lifecycle I showed you before. There's also feedback loops. There's loops within loops. And the spirit of pivoting or failing fast is very much embedded in this life cycle. I think a lot of people don't appreciate that many data science ideas don't really get past the first few stages because they're just not viable. So that ability to pivot or fail fast is very much alive in this model as well. So what I wanted to do today was to bring this to life. So I've set myself the challenge of taking a solution end-to-end using Fabric. And I've chosen the the Titanic data set. And I came across this actually during my master's. This was set as our kind of initial challenge for us to build a simple binary classification model to predict whether passengers on the Titanic would have survived or perished. And the way this worked within our class, it was really good. The lecturer set up a private Kaggle competition, and he put all the students into the competition, and we were all up till 4 a.m. in the morning, trying to beat each other on the leaderboard. It was really good. So I thought, why not use this? It's a really simple data set. It's something everyone understands. It gets us away from, looking at the details of the kind of data science process, and allows us to look at the process of flow of value and feedback loops, as I'll come back to through the presentation. And the way I've tackled this is I'm going to create 2 data products. The way I've kind of positioned this solution in my mind is that there's 2 data products here. The first one is about generating some diagnostic analytics over the data. So I'm going to use a sort of data engineering lifecycle to address that. And then I'll show you another data product later that addresses the next part in the lifecycle. And we heard from Thomas Kastrin yesterday. He ran a really good session on common mistakes in data science. I don't know if any of you were there, but one of the common mistakes comes down to data scientists not taking enough time to understand the domain, understand the data that they're dealing with. So really nailing this part of the life cycle is quite important. So my natural inclination here is, given the nature of this data product, is to apply the medallion architecture pattern. I'm ingesting some data. I'm ingesting 2 data sets, actually, as you'll see. One's the core passenger manifest from the Titanic, and the other data set's a simple set of reference data, landing that onto the bronze area of the lake, and then I can clean that data into silver, and then ultimately project that data into a gold area of the lake, so that I can create a semantic model over the data and a Power BI report. So you'll see some of these artifacts when I open Fabric in a second. Actually, the thing I wanted to focus on, because we're kind of time constrained today, the thing I actually want to focus on in this life cycle is the kind of process to silver notebook. I've actually got 2 notebooks, one that does the passenger data and another one that does the locations data. So I want to focus on one of those notebooks and just give you a flavor of how you can tackle that using Fabric. So let's have a little look at the workspace first. As you can see, the artifacts are arranged here. Let me just zoom in a little bit. Hopefully that's a bit more legible. So you can see we're using a sort of numbering scheme here just to organize the artifacts according to that: ingest to bronze, process to silver, project to gold, life cycle. Synapse, we're big fans of Synapse, has the concept of folders to help you organize your artifacts. It would be amazing if Fabric had something similar, but I believe something is in the offing there, so keep your ears to the ground on that. But for now, we've kind of used this approach just to keep the artifacts in an easy-to-understand order. So you can see I've got an overall pipeline here to orchestrate those 3 major stages, then another layer of pipelines below that to manage each of the stages. And I want to focus in on this sort of process to silver stage in particular today. Let's have a look at the validate location notebook. So we love notebooks. They're very familiar to data scientists as well. We love the fact that you've got your documentation and your code side by side. One of the features in Fabric, which is quite nice, is the concept of the table of contents. So if you've structured your markdown comments in the document, it produces a really nice table of contents for your notebook. And it just helps to tell the story. What's this notebook doing? Well, you can see that the overall objective is to validate locations. I'm creating a range of expectations using a package called Great Expectations. Let's have a look at those. So the first expectation is that this data set should have 4 columns. The next expectation is that because I know the Titanic boarded passengers in Southampton, in England, Cherbourg in France, and Queenstown in Ireland, I know I should expect at least 3 rows in this data set. Because the world is a globe, I know I should have certain values for my longitude and latitude. And finally, I'm enforcing a rule that the location code should be a single uppercase character using a regex expression. So the next stage in the notebook is to load the data. So this is quite straightforward to do in Fabric. I've connected to the lakehouse. I've actually connected to the bronze lakehouse and the silver lakehouse, because this notebook is reading the data in the bronze layer, validating the data, cleaning it, and writing it out to the silver layer. So I've connected to both of those notebooks, so it's a case of just dragging the file I want to load into the notebook. And you can see here that I've got the 3 locations I'm expecting, but I've also got a kind of bad record. This is a spreadsheet, so it's subject to human error. I'm sure we're all familiar with this use case. So someone's mistyped the longitude, it's well out of range, and also they've used an incorrect convention for the embark location. So then I run, having built up my expectations over the data, I can then validate the data using great expectations. So it's a simple call here, as you can see. And great expectations records the kind of index of the rows that have had validation issues. So I can immediately remove those from the data and generate a clean set of data. And I can write that to the lake. And this is a really nice pattern to follow. Here I'm choosing to kind of fail elegantly. I'm going to continue with the data that is clean and write that to lake. I could fail altogether. But another nice feature here is using the MS Spark utils package. I've constructed a JSON object which is returned at exit from this notebook. It's returned to the pipeline that's calling this notebook. So this is my process to silver pipeline. So you can see it calls that notebook I was just showing you, validate location, and it catches the output from the notebook, and then it makes a decision based on that output. If there are any validation errors detected, it uses this new Teams task to raise a message directly with the data stewards who maintain this spreadsheet, and it creates that really virtuous cycle, rapid feedback to the team that manage this data, telling them of the validation issues. I can't show you Teams, but I can show you, I've done a screen grab of what that message would look like. So this is the kind of thing that you can generate. The body of the message is HTML, so you can very easily turn the pandas data frame that contains all of the validation errors into an HTML table and put that into the message. And you can see here it's very specific information about the poor data. It's going straight back to the data stewards, and they can address this data, these issues, and fix the data very quickly. One word of caution with this kind of approach is just be very careful what you're putting into the messages. I'm exposing real data here, but I guess if this data was concerning personal data or sensitive data, you would take a different strategy. So the next stage of the process is I've now projected the data to gold. Let's have a look in the gold area of the lake. And I'm going to build a semantic model over the data. And that's very straightforward to do. Simply click here, pick the tables you want to bring into your semantic model, give it a name, and you're off. And in true Blue Peter style, I've got one I prepared earlier. Here it is here. I've called it Titanic Diagnostic Analytics. It just rolls off the tongue nicely. And if we go into the actual data model, you can see I've constructed a little mini star schema. Passengers are my fact table, passenger manifest, and I've got my dimension tables creating this star schema. So the semantic model, I've added the relationships. I've played around with the column names, because the idea behind a semantic model is to make this information more accessible to end users. So, some of the columns weren't obvious what they were. Other things you can do in the semantic model is add descriptions to columns as well, which are discoverable in Power BI. And I've hidden some of the columns that I don't think are going to be useful to end users in Power BI, so it just helps, again, the ease of building reports over the data. Next stage is then to build a report over the data. So let's have a look at that. So what we tend to find is if you get the semantic model right, the process of building a report and making that report intuitive and the ability to tell stories with that report becomes easier. I can't take credit for this. This credit goes to Paul, who's sitting in the audience today. He's done a great job just turning the semantic model into something rather engaging for end users. But you can see here, I can start to understand the demographics. Who boarded the Titanic? What was the age profile? What was the gender profile? I can then look at interesting metrics around who survived. You can already see some interesting patterns emerging here. One theory was there enough lifeboats on the Titanic? This simple graphic tells us, well, there wasn't a lifeboat space for everyone, but that certainly wasn't the issue. The number of survivors didn't even touch the lifeboat capacity. So it was clear there was something else going on there in terms of people surviving. And then we can look at some more sort of bringing some of the measures I added to the model to life. We can look at survival rates, and we can see quite stark differences between male and female, and also kind of social demographics as well around first class, second class, third class passengers. And Power BI also offers some nice analytics, such as the key influencers visual. So it's already starting to pick up already what we're getting a sense of with this data set, that gender and ticket class had a role to play in that survival rate. So what I'm trying to get at here is that I'm trying to imagine a data scientist engaging with this data set during that early stage of the life cycle, and using this to start to understand the data, and whether this data set's suitable for them to take through into training a machine learning algorithm. And I'm also imagining that this data product hasn't been produced by the data scientists. It might have been produced by another team within the organization who are looking at traditional BI and descriptive analytics. And what they've done, because this is entirely possible in Fabric, is they've certified that semantic model. They feel that semantic model is of sufficient quality to be discovered across the organization and to be put into use for other purposes. So my story then picks up from there. So we've got the first data product in place, our descriptive diagnostic analytics. We're now going to look at a predictive analytics data product. And this has a kind of slightly different architecture. You can see here I'm not using the medallion architecture. Inside this workspace, you're going to see a slightly different mix of artifacts. The kind of container for this is an experiment, and I'm going to use a couple of notebooks. I'll take you through those. First of all, to do some more exploratory analysis, and then to train and test and ultimately deploy a model. And I'm going to use the Synapse data science experience largely to do all of that. So in that first notebook, the exploratory data analysis, I'm going to show you a new feature in Fabric, which is in preview, called Semantic Link. It involves a Python package called SemPy. And you can see from the diagram, it's really about creating this connection between Power BI and the Synapse data science experience. Effectively, what it allows you to do, as you'll see, is connect to Power BI semantic model from a notebook and interact with that semantic model with the kind of idea that you could then use that as your kind of baseline or your foundation for building, training, and deploying a machine learning model. And that creates a kind of virtuous cycle. If you're building predictive models, you may be writing those predictions back to the one lake, and that creates another kind of insight that you could then go around this loop again with. So it's quite an interesting pattern that Microsoft are trying to establish using SemPy. So let's have a look at that notebook. So I'm going to switch from my diagnostics analysis workspace into predictive analytics workspace, and you can see immediately a whole different set of artifacts in here. It's a bit simpler. So let's have a look at the exploratory data analysis notebook first of all. While it's doing that, I might grab a drink. So in here, sorry, I should have had it at the top. We're again in notebook territory, but you can see here I'm importing the SemPy package. And it's a really simple API. You can see here I can list the data sets. So the way it works is it's listing the data sets that are in the other workspace, and that's driven by the lakehouse that I've connected to. So this notebook is in the predictive analytics workspace, but the data lake I've connected to is the gold layer in the diagnostic analytics workspace that I showed you earlier. So it's kind of a way of bridging from one workspace into another. So when I ask SemPy to list the data sets, it's not in this workspace, it's in the remote workspace. Oh, thanks. Cheers, Howard. Oh, that's better. So I can then choose, so you can see here it's listing the bronze, silver, gold default semantic models that you get when you create a lakehouse. I created a fourth semantic model because the default semantic models don't allow you to do things like rename columns and other things, and I wanted to create a really nice, rich semantic model, so I've created a fourth semantic model that I showed you in the report. So that's the one I'm interested in. So I can use SemPy to list the tables in that semantic model. I can also explore the metadata for one of those tables, so passengers, I'm quite interested in that. And you can see this is where the investment I've put in to building that semantic model starts to come through. So the descriptions that I added to some of the columns are there. The names that I wanted end users to see are being surfaced. So, you know, some of these columns, number of siblings or spouses, that wasn't clear what that column meant, but I can really bring that to life here. I can then discover the relationships in the model. So it's listing the relationships, and I can even visualize those. So it's playing back to me that star schema that I established in the semantic model. I can also discover the measures. So you can see I've got 4 really simple measures here. I can even see the DAX code for those. And then I can actually run DAX code inside my notebook. So here you can see I'm using the survival rate measure across the kind of key demographics. And already I'm starting to understand key things like first-class females, the survival rate was 96%. Compare that to third-class males, the survival rate was down around 15%. So it's already allowing me to start to understand the data very quickly. I can then load the data into a data frame. This is a special kind of data frame. It's called a fabric data frame, but it uses the Pandas API. So if you're familiar with Pandas, you can do all the things that you're familiar with on Pandas to this data frame. I can view it, for example. You wouldn't know this wasn't a Pandas data frame. But there's some interesting additional methods I can call on these data frames. So for example, I can find functional dependencies in the data, which is a really interesting way of starting to understand, even in a single table, how the data is structured. So let me just zip this back a wee bit. You can see the functional dependencies are discovered here in this tabular form, but I can then visualize that. And it's really interesting to see how those functional dependencies are working within the data. It helps you, again, to build an appreciation of the data set. I can then analyze the data. This is quite a nice feature in Fabric. You've got the kind of display method, but if you pass in summary is set the summary option to true, you can do some quite interesting analysis over the data. So if I look at something like passenger class, or I'm trying to find a nice age in decades, it based on the data type, it will draw a histogram or a pie chart or whatever. So it's kind of, traditionally you would have lots of cells trying to generate lots of different charts to understand the data. This is a more interactive experience to do just that. But if I do want to do some more advanced plotting and visualization, of course I can do that over the data. So box plots, looking at different dimensions and the like, or correlations over the data. But the net result of this notebook is that I've looked at the data, I've made some observations of the data, and I've developed a strategy that I want to apply when I train my model. So I've picked out the features I want to use. I'm probably over-egging it here, but what the hell. But I just wanted to sort of show the process, and I've decided what kind of feature engineering or feature preparation tasks I want to apply to the data when it comes to training the model. So this notebook's really there to sort of capture that thought process. It's a note to self next time I come back to sort of review this model about the decisions I made in terms of feature selection and the like. So that's pretty cool, Senpai. The next thing I wanted to do was then go about training a model. Now I now understand the data. Now I've looked at the features that I want to use. I'm now going to start training models, exploring models that I want to use. And this is where MLflow comes into play. Again, I'm sure some of you in the audience will be familiar with this, but it's very nicely integrated into Fabric. And it's the way I think of it, it's like Git for machine learning models. It kind of allows you to log the models that you've created. And as you play with different versions of those models, as you're playing with parameters and other things, this MLflow is your friend. It's logging all of that in the background, and that's what we're going to see. And it presents you with a really nice API, again, to create experiments, log runs, log the parameters that you've used and the like. How many people in the audience are familiar with MLflow, played around with it? Great, okay. I don't need to go into details. So if we open up a train test model notebook, you can see here I'm logging the experiment. So the experiment and model artifacts that you see in Fabric are actually not created manually. They're created by these statements in the notebook. I'm reading the data. I've decided to use scikit-learn for this, just to keep things simple. I'm carrying over the decisions I made in the previous notebook into the features I'm selecting and the strategies I want to apply to prepare those features for training the model. I'm splitting the data ready for training and preparing the features. And I just wanted to sort of visualize the one-hot coding and min-max scaling process here. I like kind of visualizing the data just to make sure everything's working the way I'd expect it to. And then I've kind of constructed this little helper method because what I wanted to do was just apply the same pattern. Every time I train a model, I want to sort of log and capture all the same metadata about that model as I do that. So you can see here each run is within an MLflow run, so that registers the run. I'm training the model, logging the parameters, making predictions, capturing the model signatures, so the input-output schemas, capturing the serialized version of the model so I can retrieve it later on, as we'll see, capturing the metrics, and I'm generating some useful output so I can play around and see how the model's performing interactively in the notebook. So you can see I've done that just here. Here I'm training a random forest classifier. You can see the specific parameters for this model, and I'm using my helper function to run the model, give it a name that appears in MLflow, and pass in those parameters. And you can see the output from from that here. So you can see that that run gets registered in MLflow with a unique name. And we'll have a look at that in a second under the kind of experiment that I've created. I can visualize the data in a confusion matrix, and I can repeat that process again for a different model and again for a different model. So the scenario here is that I'm imagining that intuitively I think I should be able to squeeze some better performance out of this random forest classifier. And I need some help. There's someone here that could help me. It's my colleague Ed. Well, I'm in the office. I know he's at SQL Bits, so how can I get his help? So another nice feature of Fabric is that I can use the comments functionality. And I can mention Ed here. Hello. There he is. Can you help? I was going to type a longer message, but let's just try and speed things up. So Ed, he shouldn't be. He's looking at his laptop. He should be paying attention to the presentation that's going on, but he spotted this message, and he's got back to me. Oh, I'm stuck then. I can't go any further. That's the end of the presentation. Hopefully he's going to come back. He's joking. Okay. Right, so he thinks I might be overfitting the model. Okay, so right, great. Thanks, Ed. You can see he's actually in this cell looking at the data. So let's change a parameter here. Rerun the model. This notebook is probably timed out, so that's probably going to fail. But imagine, it's that interactive loop. So I really like this. It's shortening that feedback loop, isn't it? I'm stuck. I need some help from a colleague. I can bring them straight into the notebook, and they can see the context, and they can offer their help. So whilst I've been running this notebook, in the background, Fabric has been faithfully logging all of my runs. So the structure is you've got an overarching experiment, which acts as a container for all of the runs that I've done. So all of the models are registered here. Hopefully this will load up. So you can see every run is registered. I can also jump straight to a particular model. Sorry, I'm just having a problem navigating here. Oh, zoom in a little bit, okay. There we go, how's that? I'll just jump back to the workspace. So I was looking at the random forest classifier. So if I drill into that, we can look at the different metrics that we captured over the different runs. I found there's a little bit of a lag between you doing a run in the notebook and that run coming through into this view, so you can see some of the data sort of lagging what we've been looking at. But let's say once you change the resolution of the screen, everything moves around. So that you can view the kind of metrics associated with the different runs that you've done and make a decision about which version of this model that you might want to deploy and make use of. So let's do that. Shall we try and, this is a live experiment. Let's say we're going to choose version 12 of the model as the one we want to deploy into production. So it's just a case of selecting that version. I can see this is the one that gave me 80% accuracy. So let's say that was the acceptance criteria set by the business. The model had to achieve that level of accuracy. I'm happy with precision and recall and other metrics that I might be interested in, so I want to now deploy this. And I've completely lost where it is. Where is it? Oh yeah, apply this version. It's just because it jumps around. Apply this version, there it is. So I'm going to use a wizard to do that. So I select the lakehouse. So I've created a lakehouse in this workspace that now contains new data that I want to run my predictions over. So I've prepared some data already. But imagine you could have a pipeline ready to sort of ingest that data from upstream production systems. I can then choose the table, which I've imaginatively called new data. And in here, once the preview loads, you'll see I've captured the Smart family. So it's me, my wife, and 2 kids, because I was interested in understanding if we were on the Titanic, what would have happened to us. There we are. So all the different demographics are captured there. I decided we would be second class, not first class. So, and then you've got this process of mapping from your kind of new data onto the model schema, input schema. And I kind of cheated here. They're pretty much identical schemas, but you can imagine using this to sort of map across. And then I can decide what I want to push the predictions into. New table, new column, survival prediction. So what it does is it creates a single cell of code that I can put into a new notebook. So I'll call it SQL bits, predictions. And create the notebook. So again, this is interesting. It's kind of easing you through that process of taking something that you want to productionize and putting it into production. Oh, great. The demo gods have got me. Oh, here we go. I'll close a few things down. I don't think I'm going to look at that again. So now I can run that. And you can see the code. Basically, it's reading the data from the source table, the new data table that I've created in the lake. It's retrieving, remember it was a random forest classifier model that we decided we wanted to use in production, and in fact it was version 12 of that model that we selected. So it's retrieving that from MLflow, and then here it's running the predictions over the input data using the transform operation, and then it's writing those predictions back out to the table that I called new predictions. So let's now have a look in the lake. No surprises. I'm sure you can guess what's going to happen to the Smart family. Let me see, where's that lake? There it is. So if we go into the lake, that's a bit, if we refresh, hopefully we'll see a new table. There we go, new predictions. Drum roll. But you can see survival prediction. I don't make it, but thankfully my wife and kids do, so at least I can perish with a happy thought as I sink below the waves that they're okay. So there you go. So that was a kind of end-to-end demo. The interesting thing about that notebook is that you probably want to tidy it up a bit, and you could wrap it up with some logging and the like, but it's just nice, the flow that it takes you through. Great. So we've done that. We've done the deployment. So the other thing I was quite interested in was looking at where is Fabric versus Azure Machine Learning. And Azure Machine Learning is obviously a much more mature product, and it gives you a lot more choice around things like the types of compute that you want to use. There's a wide array of options. And I think with Azure Machine Learning, it kind of encourages you to use different compute for experimentation, different compute for training, potentially even different compute for productionization, deploying the model. I think the nice thing about Fabric, it kind of simplifies all of that. You don't have to worry about these kind of choices. You've got your kind of serverless Spark engine. That's what you're going to use throughout that whole life cycle. So I think that, to me, is, some people will see it as potentially a limitation. You've not got as much control, but I think it also, the kind of Spark engine right across all of those different stages of the life cycle, I think is quite attractive. The Git integration is fully supported on Azure Machine Learning. As you can see, if I flip back to the the workspace, not all artifacts are currently supported for Git. So this repo is synced to source control in Azure DevOps, but you can see not all artifacts are currently supported for Git integration. But I believe Microsoft are working on that as well. We should see full support across all artifacts for Git source control soon. I think another thing about Azure Machine Learning is it kind of assumes that you would have done a lot of your kind of data prep upstream, whereas obviously what I've shown you today, I took the time to sort of show that, was that you can bring the whole end-to-end lifecycle together under one platform. The deployment of the model I showed you is for batch only, so you can only deploy the models at the moment for batch operation, whereas in Azure Machine Learning, you can deploy models for interactive predictions behind an API. Again, I think this is something that's in the roadmap for Fabric, so it'll be interesting to see how that's implemented when it comes to life. Data integration in Azure Machine Learning, you've got concepts such as data sets and data assets, are kind of layers of abstraction over the different data sources that you want to connect to, for good reasons, to sort of store credentials and share connections to data. What's interesting about the kind of Fabric experience is you don't have to worry about those new concepts. You're dealing with kind of one lake, shortcuts, pipelines, and the like, things that I think will become a more pervasive common language across data teams. The managed feature store isn't available in Fabric at the moment. Be interesting to see if that comes down the line. MLflow is supported across both. One thing I really miss in Fabric that isn't available at the moment is the kind of tools you have in Azure Machine Learning for responsible AI, explanations, and fairness around deploying models that are fair across different demographics. So it'll be interesting to see if that comes along as well. The superpower I think that Fabric obviously has is what I showed you today, which is Senpai, that ability for you to connect to semantic models and use those as the source of truth. And then finally is that sort of developer experience. I think Azure Machine Learning sort of encourages you to use notebooks for exploration phase of the life cycle, and then to sort of transfer your code into jobs that you then deploy. I think what's interesting about Fabric is it's entirely feasible to use notebooks right across the whole life cycle. So that was just my sort of side-by-side assessment of the two platforms. There are opportunities as well to use them in tandem. Pipelines in Fabric allow you to trigger activities in Azure Machine Learning. There's also a new one-lake data store in Azure Machine Learning, so it allows you to connect Azure Machine Learning to data sources that are in the one lake. And you can do cute things with shortcuts and blob storage and things to sort of integrate the two platforms if that's what you want to do. So it's maybe not a one or the other type decision, it's how you can potentially use capability you might have in Azure ML alongside Fabric and maybe use the different platforms for different use cases. So that's what I've demoed today, two data products, both on Fabric, one tackling the kind of data prep, early exploratory data analysis, and that providing the sort of foundations for the downstream predictive analytics. And I think it's quite interesting how maybe a lot of organizations at the moment have different teams doing these activities separately, working in silos, using different technology stacks. So there's an opportunity here for the work that's been done in more traditional business intelligence teams to be leveraged further up that sort of capability curve by data science teams. So I think that's an interesting concept, and it plays to the kind of data mesh principles that we're hearing more and more frequently in our language. And then sort of coming back to the data as a socio-technical endeavor, hopefully I've shown you some techniques today around how you can accelerate that flow of value, how you can generate those feedback loops and react to those feedback loops in really dynamic ways to increase the cadence of this virtuous cycle that we all want to establish. So that's pretty much it, everything I wanted to cover. I've whipped through a whole bunch of stuff there very, very quickly. A lot of the stuff I've been talking about you'll find on our blogs. There's a link there to those. The plan is to do a series of short YouTube videos about this particular use case, but I'd really appreciate your feedback on what you've seen today. And to do that, I encourage you to use the SQL Bits feedback link that you see there. I'm not sure if you're aware, but the link, every piece of feedback generates a contribution to a charity of your choice. So for that reason alone, I'd encourage you to provide some feedback, and also it enters you into the prize draw that we'll have at the end of each day. But I'd honestly just like your feedback about how the session's gone today. What have you learned? Anything else that you could provide would be much appreciated. So all that remains to be said is thanks very much for coming along, and if anyone's got any questions, I'd do my best to answer them. Thank you.
MLflow or Great Expectation? Can this method be used with confidential data?
So the question was, I don't think that came across the. So the question was, when the data is sent to MLflow and Great Expectations, can that be used with confidential data? So everything I've shown you today has been contained within a workspace. So MLflow, when you create an MLflow experiment, that's within the workspace that you're running the notebook. So all of the logging and metrics and information that's captured there is contained within that workspace. And when I ran Great Expectations, whilst I'm importing a public package there, when I run the package, again, it's within the context of the notebook. And then again, any of the outputs that were generated were generally contained within the workspace, apart from the one example where I generated that Teams message. So that's the only place I'm saying caution is I'm choosing to send a Teams message outside of the context of my workspace. For good reason, I want to engage people and get them to spring into action. But I think that's the one area where you could potentially leak information. But otherwise, the workspace is that sort of security container, and you can manage the permissions on that workspace, who has access to it and what levels of permissions they have. So I think the solution I've shown you today is secure, or as secure as you need it to be. Oh, 2 questions.
Sorry,
Thank you. You mentioned about the feature store being apparent in Azure Machine Learning, but not currently in the Fabric side of things. Do you think there is a place still for feature store to come across as an actual feature as Fabric, or do you think Fabric just covers that sort of natively?
Yeah, I was kind of mulling that one over myself. I don't think you'd miss it if you wanted to go ahead and start building solutions and having that concept of feature logic that you want to reuse over and over again. There's other ways of achieving that. So yeah, I don't think it's a blocker at the moment, but it'll be interesting to see if they do carry it over. It's a nice concept, but again, you can achieve it in other ways, perhaps by having Python classes and methods that you just maintain separately in packages and the like. So yeah, it's a good question. It'd be interesting to see if that gets prioritized as something that they tackle soon, or whether it gets pushed further down the list.
I would like to know if it's possible to have an exchange between Jupyter notebooks and Fabric notebooks. So can I import the notebooks?
Mm-hmm. Yeah, so let me see if I can find that. In the workspace, where's my workspace gone? it's quite confusing, but if I go to the data engineering experience, oh, have I? I timed out, that's why it's, I wonder why that is. Try that. Sorry, folks. But yeah, if you go to the data engineering experience in Fabric, there's a import notebook option, and you just navigate to IPYNB file, and you can import it in, and that's you. You've got your starter for 10. Okay. I think we better finish up there. We're out of time, but I'll be hanging around if you've got any other questions. But thanks again, everyone, and enjoy the rest of the conference.